Okay, this is a lesson on slope-intercept form, and so we're building off of what we learned in the last lesson, which was point-slope form. So what you'll see here is that slope-intercept form looks as follows. It's actually a little bit simpler than point-slope form. I think one of the reasons why we teach point-slope form is that once you accept slope-intercept form, that it's a little bit harder to accept point slope as an alternative. So we kind of start with the harder and then move to the easier. So I think you will find this a little bit easier to understand, even if you're comfortable with point slope. So what you'll notice with slope-intercept is when you have an equation in this form, and here's an example, y equals 2x plus 3, the number that comes before the x is the slope, and the standalone number, or the constant, is the, we're going to call that that's the y, a lot of people call it the y-intercept, but more specifically, the b is the y value of the point. It's the y value of the point on the line where it passes through the y-axis, and that's called the y-intercept. And that's called the y-intercept. And at that point, the x value always equals 0, so it's b is really a part of a point that is 0, b. So let's try to go ahead and graph this equation right here. If you have y equals 2x plus 3, and if the slope is 2, that's going to mean we have a rise over run of 2 over 1, and the y-intercept is the point 0, 3. So we need to graph a point first, and the y-intercept is the point we're going to graph, so that's the point 0, 3 right there. Make that a little clearer. And then I'm going to go use my rise over run up 2 and over 1. And I might do that a couple more times just to make it easy for me to draw the line. And then I'm going to draw my line through those points. And that's how I use. And whenever I have an equation that's in slope-intercept form, one of the advantages of it is it's very easy to graph, because you're going to graph the y-intercept, and then you're going to use your slope to find as many other points as you want. So let's go to the next page. Now here I have an equation that's not in slope-intercept form. Negative 2x minus 6y equals 5. I want to convert it to slope-intercept form, and remember this is slope-intercept form, so I want to modify the equation so that it's in that form. So what I want to do here is solve for y. So it says, so you want to convert the equation to slope-intercept form and give the slope and the y-intercept of the line. Let me just fix that little of the line. Okay. So, so I'm going to take this equation, negative 2x minus 6y equals 5, and I'm going to solve it for y. And that means I'm just going to be rearranging the equation where y will be alone by itself. So I'm going to add 2x, and so that it looks in this form right here, I'm going to use the commutative property, put the 2x first, and then so what I'll have next is negative 6y equals, instead of saying 5 plus 2x, I'm going to just say 2x plus 5. Now, then I'm going to, let me just rewrite the equation, and I'm going to multiply both sides by, or I'm going to actually multiply by negative 1/6. I could divide by negative 6, but it'll be a little easier if we use reciprocal here. And I'll have y equals, when I distribute the negative 1/6 to the 2x, I'll have negative 2/6x, so that'll be negative 1/3 x. And then I'll distribute it to the 5, and I'll get minus 5/6. So my slope is, for this equation, is negative 1/3, and my y-intercept is the point 0, negative 5/6. So it's just it's not a whole number, the y-intercept. So now let's go to the next one. So I'm going to find the slope-intercept equation of the line that has a slope of negative 3/4 and passes through the point 0, 5. So what I'd want you to notice here is that this is really giving us the it's really giving us both this is a very easy problem because it's both giving us the negative 3/4 and it's giving us, notice that because x is 0, that's where the line, and y is 5, that's where the line, this is the y-intercept, so this 5 is going to become my b. This negative 3/4 is my m. So this problem becomes y equals, I substitute the negative 3/4 for the m, and I put my x, and then I say plus 5. And let's go ahead and circle this one up above here as my answers up here as well. Okay, now find the slope-intercept equation of the line that has the slope negative 2/3 and passes through the point negative 6, 7. Well, in this particular problem, they're no longer giving us the y-intercept, so again, let me put slope-intercept form. Now, a reminder, just as in point slope, the x and the y stand for all the possible x and y's, all the possible points on the line. So if I'm given a point here, I can substitute the negative 6 in for the x and the 7 for the y. I've got my slope, and then I'll find out what my y-intercept is, and then I can write the equation in slope-intercept form. So I'm going to substitute the 7 for the y and the negative 6 for the, the negative 6 for the x, and then the negative 2/3 for the m, and then I'll be able to solve for b and be able to then rewrite the equation. So I'm going to write this 7, that's substituting the 7 for the y, the negative 2/3 for the slope. I'm going to substitute the negative 6 for the x, and then plus b. So I'll solve for b here. Now that won't be my answer, but that will enable me to get to the answer. So I have 7 equals, when I multiply negative 2/3 of negative 6, that's going to be positive 4 plus b. I'm going to subtract 4. And I'm going to get b equals 3. So now I'm going to rewrite the equation y equals, I'll substitute that slope in there of negative 2/3 x, and I'll substitute this newfound value for b in for the b right there, and I'll get plus 3. And so that's the equation of the line. So if you were to graph this, line, whoops, lost everything there. Let me pause that and get that all back down for a second. So what we found is that this equation right here, if you were to graph it, it would have this y-intercept of 0, 3, and this slope, and you would notice that the line goes through this point and obviously has this slope because we're going to use that slope to create the line, but this point would actually be on the line. And if you don't believe me, go ahead and graph that and you would see that it contains that point. One other thing you would want to know is that every point that's on a line would make the equation true, and if I substituted -6 here, I would get that this is +4. +4 plus 3 equals 7, so it's a solution to the equation. So let's do this next one here. Okay, so let's do this next one. You have find the slope-intercept equation of the line that passes through these 2 points. Now we're no longer given the slope and we're given 2 points, so more than we need, but we are going to have to find the slope here. So I'm going to m equals, and I'll call this point 1 and this point 2, and I will, so I'll say 5 minus 1 over 2 minus -3, and that would equal 4 over 5. So that's my slope. I can use either of these points to plug into slope-intercept form for the x and the y and to find b, and once I find b, I can write the equation that I'm looking for. So I'm going to use the one with the 2 positives. That'll make this just a little bit easier. So I'm going to say y equals 5, my slope is 4/5, and my x is 2 plus b, and so this will be 5 equals 8/5 plus b, and if I subtract 8/5 and subtract 8/5, remember that 5 is 25/5, so remember this is 25/5, so when I subtract 8/5 from 25/5, so when I subtract 8/5 from 25/5, I'm going to have 17/5 equals b. So my equation is y equals 4/5 x plus 17/5. And notice that I used this point right here. I would have gotten the same equation if I'd used that. Just the work would have all come out to 17/5 for b, no matter what point I used there. Okay, so now next problem is to write an equation in slope-intercept form that passes through the given points. That'd be this 2, 5, and is parallel to the given equation. So basically what they're doing, what's happening here is I'm indirectly being given the slope, and I have this point, and I can get my equation if I have the slope, and then I'll use this point to get the y-intercept for the line I'm looking for. So I am going to have to rearrange this equation by subtracting 4x, because I've got to see what my slope is of this line. That's my purpose here. Then I have -y equals -4x plus 7. Then I'm going to multiply both sides by -1 to get rid of that negative sign. And I'll get y equals 4x minus 7. So my slope that I was looking for is 4. And so I'm going to then, from the new line I'm looking for, I've got to use this point right here. So I'm going to say 5 for, again for slope-intercept, it's y equals mx plus b. So I'm going to substitute 5 for y. So y equals mx plus b. I don't know what b is, but I have a point on the line, so I can substitute the y for the 5 for the y. I've got my slope now, which is 4. I've got an x value for one of the points on the line is 2. And I get 5 equals 8 plus b. Subtract 8. And I get b equals -3. So now I have my slope, my y-intercept, and I have my slope. So my equation is y equals 4x, and then so I've got to use the y-intercept of -3, and you can see that the equation above here had a different y-intercept of -7, but had the same slope. So this is parallel to this line, and it will pass through this point because of the work I did here to calculate slope. Now looking down below here, I've similar problem, but now I'm going to be dealing with a perpendicular line. Remember, perpendicular lines have slopes that are opposites of reciprocals. I want it to pass through this point, and I want it to have an opposite reciprocal slope to this line. Well, I've got to do some work on this equation. Got to get y by itself, so I can actually do that by just getting y on the right side just as easily. And I'll have 5 force y equals x plus 2. And then I'm going to multiply by 4/5 on both sides. And I'll get 4/5 x plus 8/5 equals y. So just write that out in normal slope intercept. That'd be 4/5 x plus 8/5. Now I'm really only concerned in this equation with this slope right here. So the slope of the line I'm looking for needs to be perpendicular. So I'm going to pick the slope that's the opposite reciprocal of that. So the slope I'm going to use is m equals -5 fourths. That's opposite of the reciprocal. So the reciprocal of 4/5 is 5 fourths, and with the opposite of that, so -5 fourths. And now I've got to move everything up here a second. And I've got to incorporate this point right here of 4, -2, and this slope here to get my perpendicular line that will pass through that point and have this as its slope. So I'm going to say -2 equals -5 fourths times 4 plus b. I've got to get the b for my new line. And then I'll have -2 equals, this is going to be -5 plus b. And that will be, I'll add 5 to both sides. And I'll get 3 equals b. So my equation is y equals -5 fourths x plus 3. So that's the slope-intercept equation of the line that passes through this point and is perpendicular to this, well, it's perpendicular to this, the slope for this line, which is actually 4/5. And so there's my equation. I got let me see if I can make this just a little bit bigger. So you've got a auto repair shop, has an hourly rate for repairs, and it costs $69 for a 1.5 hour radiator repair, and then it costs $230 for a 5-hour transmission overhaul. What is the hourly rate? So let me let x here equal the number of hours for repairs. and let y equal the dollar cost of the repairs. It's actually giving me 2 points here. It's giving me 1.5, 69, and it's giving me 5, 230. I'm going to need to get my slope first, so I'll call a 5, 230 my 0.2, so I've got 230 minus 69 over 5 minus 1.5. So I'm going to get m equals 230 minus 69 is 161 over 5 minus 1.5 is 3.5. So 3.5 is 7/2. So that means m equals 161. M equals 161 divided by 7/2, so times 2/7. And let me calculate that real quick. Okay, I'm realizing I forgot to turn the record back on. So in the second problem, you have a copier that costs $1,050 when new, and will have a salvage value of $90 when it's replaced in 8 years. So basically what's happening is copier is losing almost all of its value. That's what depreciation means. What's the rate per year? So we can really consider this to be 2.0, 1,050, 890. X is the number of years. That's your 0 and your 8. When something's new, 0 years have passed by. This is what it costs in the beginning. 8 years later has a salvage value of $90. I'm going to consider this to be 0.2, so I can keep a positive numerator here. But the negative or loss of value is going to show up in the denominator. And then I'm going to, so 960 divided by 8 goes into 90, 8 goes into 9 one time. So let me just get my slope here. M equals, so I end up here with, it has a depreciation rate of negative $120 per year. Okay, we're going to stop there with this lesson.